lab 1, we had to design an experiment that helped us to determine how a certain variable affects the energy in a system with a bouncing ball. For our experiment, we decided to change the mass of the ball while keeping the other variables, such as the height, constant. We did 4 trials using a wiffle ball, a tennis ball, a golf ball, and a bouncy water ball. We kept the height at which we dropped the ball from constant at 1 meter. The tennis ball weighed 50 grams, the wiffle ball weighed 15 grams, the bouncy water ball weighed 105 grams, and the golf ball weighed 44 grams. We videotaped each trial and uploaded them to Tracker, where we recorded the ball's position every few frames to make tables and graphs of our data. We then made position versus time, velocity versus time, and acceleration versus time graphs for each of our trials. After collecting our data, we determined the amount of gravitational potential energy and kinetic energy present in the system at various times. We used the equations gravitational potential energy equals mass times the acceleration due to gravity times height, and kinetic energy equals 1/2 mass times velocity squared. For example, these are our calculations to find the gravitational potential energy for each of the trials at time 0 before the ball was dropped. And then here are our calculations to find the kinetic energy in the system for each trial at the 15th step that we recorded in Tracker. After collecting and analyzing our data, we came to a few conclusions. 1, the greater the mass, the greater the gravitational potential energy is at a given height while being held above the ground. And 2, the greater the mass, the greater the kinetic energy is at a given height after the ball has been dropped. These conclusions make sense given the equations for gravitational potential energy and kinetic energy, as well as the fact that energy is always conserved in a closed system. While collecting our data, we attempted to minimize error by dropping the ball from a constant height, zeroing out the scale before weighing the ball, and using a tripod to keep the camera at a 90-degree angle with the ground and at a constant distance from where the ball was being dropped. To get a quantitative estimate of our error, we graphed the gravitational potential energy and the kinetic energy over time and found the standard deviation. These were our calculated standard deviations. Given that our standard deviations that we calculated are relatively small, we can conclude that there was very little error in our experiment, and the conclusions that we came to are correct.